let's take a little closer look at this picture. So if we look at the final, so we have two coordinates here. Okay, great. So some sort of y value, some sort of x value. All right, so good. And then here we go. So this vector here is the total final momentum, and this angle is the one you calculated with the arctangent for that one. And it also gives you the coordinates. In other words, this is the x coordinate, and that's the y coordinate. Okay, great. Then we have the initial momentum, and I shouldn't have to tell you that the initial ones will be bigger, slightly bigger. All right. Aha. Yes. So this vector here is the total initial momentum, and that's at its angle too. You calculate it. And that also has a pair of coordinates. And so look, if momentum was 100% conserved, these angles would be the same. The final momentum would be equal to the initial momentum, but we have some error here. And the error is represented by this difference here, this distance between these two. Well, since we have the coordinates, huzzah, we can now find the magnitude of this error vector with the distance formula. Yes. Okay, and then once we find this, let's go ahead and grab the percent fractional error. Use that same magnitude you just found, divided by the magnitude of the total initial momentum, multiplied by 100. That's one way to examine our data. Good. Let's look at a second way. Okay, so now we need a different piece of paper. The last data sheet you'll have. Okay, so to get started, we need to start transferring over information. In other words, what we want is we want to write the vectors. We want like a vector here for the initial. This is the initial one, and then the other one we'll get here, and then here, and then here, and then we'll find our difference here. Okay, so first thing we want to do before we start that is we want to, I recommend you copy over what we need from your original sheet. Okay, so in other words, the vector that was on the bottom on the right, that information is from PI1 and theta I1. That's here. Okay, right above that one will be P2I, theta 2I. That's here. Grab those numbers from your sheet. And then the bottom left, P1F, theta 1F. That's up here. Okay, and then the last one on top of that, P2F, theta 2F, that's right here. Okay, so now that we have those, we've got our ruler and our protractor, and we have to decide the scale. I recommend the scale be 1 centimeter is equal to 1,000 momentum units. Simply because, look, we have 11,000 momentum units here. That would correspond nicely with 11 centimeters off our ruler. And then here, 5.5570. Well, that would be a nice 5.57. Okay, so let's start near the center. That will be our starting point right at the center. Okay, terrific. So I'm gonna plot this one. So our first angle measured off the positive x-axis, 45.5. Take my protractor. Okay. 45. 45, right? Yes. Yes, good. So I know that's where it goes, and now I need 5.57 centimeters. So now let's see here. Yes. So 5.57 is right there. And there it is. All right. So this vector here is P1I. And just a reminder, that angle we just found was measured up the positive x-axis theta 1I. All right, terrific. Now we want to put this next vector for the second part of the initial momentum. We want to put that tail at the first one's tip. So I need my protractor again. And I put the crosshairs right at the tip of the last one and make sure that the horizontal crosshairs is parallel with the horizontal lines. All right, I need 135.1. Aha, 135.1. Yes, right. Got it. Yes. And I need 11.00 centimeters. So now, yeah. Okay. So great. So this is P2I. And just a reminder, that angle was measured off of the positive x-axis. And look at what we can do now. Let's connect the tip from the last one with the tail of the first one. Yeah, look at that. Great. So now look, this vector here is the total initial. Now I can find it a second way. I now measure it, find its magnitude, use the scale to convert it back to real momentum units, and compare it with the one I found in the first method. Awesome. And then I can find its angle too, and compare that angle with the way I found the first method. Terrific. Okay, so now do the same thing on this side. Plot these vectors, and it'll look something like this. Okay. So this one right here would be P1F, P2F, and then this would be P total final. And same thing, I can now measure this magnitude, convert it with a scale factor, measure the angle with the protractor, and compare the magnitude and the angle to what I found before. All right, one last bit of business here. Remember I said that if momentum was completely conserved, these total vectors from the initial and the final should be right on top of each other, but they're not. In other words, we have, well, the P total initial, well, it should equal the P total final, but it doesn't quite. There's now some sort of error, delta P, that we saw before, and that's represented here. This. It's going this way. This is the delta P of the error. And now you can measure this magnitude, convert it, and compare it to the one you found before. Two ways to find the same thing. How cool is that? So, in closing, I would just like you to know that if you would prefer to call me Lord Vector, I'm okay with that too. Goodbye. Good luck, future Sith. Long live the Empire!